Hi everyone, this is Mishal Salim, and today we will practice some A-level math questions, which is from the topic logical consequence and equivalence. So first of all, I want to show you some symbols, some letters that is being used in the logical consequence and equivalence. So let's see. In logical consequence and equivalence, uh, we have two statements, and let's name these two statements as A and B. Let's say I have a statement A and then I have a statement B. So if statement A is true, and because of statement A, statement B is true, then we use this line, which means A implies B. A implies B means that A is true, and because of A, statement B is true. So we use this line. You'll see in this example that how we use this symbol, this line. Okay, then I have another condition, and in this condition, let's say let's now look to these both statements in the reverse way, in the backwards way. Let's see that statement B is true, and because of statement B, statement A is true. Then we use this line, which says B implies A. Okay, also just let me write down this. Okay, in the first one it says A implies B, and the second one it says B implies A. Okay, now there is a third condition, and in the third condition, let's say if statement A is true, then because of statement A, statement B is true, and if statement B is true, then because of statement B, A is also true. So they are both true, they both implies each other. So if two statements implies each other, then this is logical equivalence. And if one statement implies the other one, then there is a consequence. Obviously, it is obvious from its meaning. Then there is a logical consequence, and if both statements implies each other, then there is logical equivalence. Okay, now let's see these examples. Okay, now the first one is for an integer n is an even number. Okay, statement B is n is a multiple of 4. Okay, now let's think of some even numbers. Let's say 2, 4, 6, 8. Okay, so 2, 4, 6, 8 are multiple of 4? No, not all even numbers are multiple of 4. 2 is not multiple of 4. 6 is not multiple of 4. Okay, so 8 doesn't imply B. This is obvious. Okay, we have cleared that. Now look backward. Now we look backward in the reverse way. Okay, so n is multiple of 4. So if n is multiple of 4, then it must be an even number, because 4 is an even number, and its multiple will also be an even number. So a is an even number. Okay, so if a number is a multiple of 4, then it must be even number. So B implies A. In this condition, we will use this line, this symbol, which says B implies A. It's clear, it's that easy. Okay, now the second question. Okay, in the second question it says x equals 2. So if x equals 2, we will put x in this statement and see what happens. Okay, so wherever you see x, put 2 instead of x. I mean, use the value of x and substitute it. Okay, so 2 square plus 2, then minus 6, and let's see if it's equals to 0 or not. So 2 square is 4, and 4 plus 2 is 6, and 6 minus 6 is definitely equal to 0. So if x equals 2, then it satisfies this equation. So if x equals 2, then it definitely satisfies this equation. So it means that A implies B. So we can use this line that A implies B. Okay, we will also have to check, we also must have to check the reverse, the backward way. Okay, so x square plus x minus 6 equals 0. Then x equals 2. So whether x equals 2 then or not, we will see that in this example. Let's factorize this expression and see whether the value of x equals to 2 or not. So for that we will solve this equation, which is a quadratic equation. So now we will solve this equation and find out the value of x. Let's factorize it. So x square plus x minus 6 equals 0. Okay, we can solve it by factorization, which is an easiest way to solve a quadratic equation. For factorization, we multiply first and last terms of the equation, of the expression. So if we multiply first the first and last, so x square and 6 is 6x square. I will write it here because this is some rough work, some rough calculations. Okay, so it is 6x square, and not only 6x square because 6 is negative. So x square times negative 6, so it will be negative 6x square. Okay, now we have to find two parts. Okay, in the middle of the equation there is x, so I will write x here. Okay, now we have to find two parts here. When we multiply these two parts, so the product of these two parts will give us negative 6x square, and the sum of these two parts must give us x. So now we have to find these two parts. So I need you to think of these two numbers. Okay, pause the video and think of these numbers, give it a try. If you can't, then again play the video and see how I do it. So let's see. Okay, so the two parts are 3x. The number first part is 3x and the second part is negative 2x. Okay, it is obvious. So 3 minus 2 is 1, so 1x. So the sum definitely gives us x. Now let's see the product. So 3 times negative 2 is negative 6, and x times x is x square. So the product of these two parts gives us negative 6x square, and the sum of these two parts gives us x. So it is true. Okay, let's move on then. X square. Now instead of this, the middle part, I will use these two parts. So plus x, instead of this plus x, I will use 3x plus 2x minus 6 equals 0. Okay, then in the next step we factorize each two terms. We factorize by grouping. We will now make groups and factorize them. Okay, so first let's factorize these two. So here x is, we will take x as common because x is common, and we will be left with x and then plus 3. Okay, if we try to factorize these two, So here 2 is common because 2 is here and 6 is multiple of 2. So we'll take 2 as common and we will be left with x minus 3. And then equals and 0. Okay, now again we will factorize because on plus sign term terminates. So this is one term and this is the other term, and in these two terms x plus 3 is common. X plus 3 is in sorry, this is a mistake. There is a mistake because this is negative 2x. Because here we take it as negative 2x, and if that is negative 2x, then this must also be negative. Then it must also be negative, and if we take negative x as common, then negative times negative is plus. And if you multiply these two now, so negative plus is negative and 2 times 3 is 6. So it is true now. Okay, so x plus 3 is common in these two terms. So we will take x plus 3 as common. So x plus 3 taken as common factor, and we are left with x minus 2 here, and then equals 0. So now in this case, by zero factor property, either x plus 3 equals 0 or x minus 2 equals 0. So I will write it here, either x plus 3 equals 0, and if x plus 3 equals 0, then the value of x is negative 3. Okay, and if x minus 2 equals 0, if x minus 2 equals 0, then the value of x is 2. So here you see we got two values of x. And why two values of x? Because this is a quadratic equation and it has the degree 2. So whenever the degree of equation is 2, it will give us two roots. And if the degree is 3, degree means highest power in an expression. So here the highest power is 2, so it means the degree is 2. And if the degree is 2, it will give us two roots. If degree is 3, it will give us three roots, and if the degree is 4, it will give us 4 roots, and so on, vice versa. Okay, so here you see x can either be negative 3, it may be negative 3, or it may be 2. Both the values are true. So we have seen that plus 2 satisfies the equation. Now let's try negative 3. So if I try negative 3, so negative 3 square plus negative 3 and then minus 6. Let's see, so minus 3 square is 9, and minus 3 and minus 6 is minus 9. So 9 minus 9 definitely gives us 0. So this equation is also equals to 0. So this means that negative 3 also satisfies this equation. So it means negative 3 and 2 are both correct and true values of this equation. Okay, so here now let's see the question again. So x equals 2, so this satisfies the equation. That's why A implies B. So whether we can say that B implies A, so we can't say that B implies A because B doesn't imply A. Why? Because B has two values, that is negative 3 and 2. So if B implies A, then there must be 2 and a negative 3. So we don't see a negative 3 here. That's why B doesn't imply A. So we will leave this one here like this. Okay, now this one, the third question. So statement A is x equals 1. So if x equals 1, then the statement B is x squared equals 1. So let's put this one in this equation and let's see what happens. So 1 square is definitely 1 because 1 square means 1 times 1. So 1 times 1 is 1. So if we put this expression, the value of x in this one, so b a implies b. See, this means if a is true, the value of x is 1, then the statement b is true. So a implies b. So now the question is whether we can say that b implies a. Will it be true? Let's see whether it can be true or not. So x squared equals 1. X squared equals 1. So now we will find the value of x, not the x square. It is x square. Now we'll find the value of x and let's see then whether it is 1 or not. So to find the value of x here, we will square root both sides. So the square and square root can both cancel each other, and x is equal to plus minus 1. It is the rule to find a square root of a number. If a number comes out of the square root, we take it as a positive or a negative. So this means that x square is a degree 2 equation. So degree 2 equation must gives us two values. So here are the two values. One is plus 2 and the other one is negative 2. Sorry, not 2. What am I doing? I didn't do this. Who did this? Okay, so it is 1, either plus 1 or negative 1. So if we say that b implies a, then there must be positive 1. So it is here, positive 1 is already here. Then there must be a negative 1. So if there is a positive 1 and a negative 1, then we can say that b implies a. So here in this case there is only 1 and there is no negative 1. That's why b doesn't imply a. Only a implies b. And that's the end of it. Thank you.